Good morning, I'm Steve Thomas, host of public television's This Old House. Now, usually you find me standing in front of an old house somewhere, but today I'm at the Dedham High School. Now, Dedham is one of the old colonial villages just south of Boston, and it's just a couple of miles from our current This Old House project. I'm here today with the Environmental Protection Agency, and they have become increasingly concerned about the quality of the air inside our nation's schools. Now, we'll be outlining some simple steps you can take to keep your ventilation equipment up to snuff, to keep the air inside your school as clean as possible. Hey, how you doing? Now, indoor air quality is nothing more than the quality of the air inside a building or school. And it's important because students spend about 90% of their time indoors. Now, a figure that I was astonished to hear is that the air inside a school can be 2 to 5 times more polluted than the air outside. Now, I'm supposed to meet my friend and colleague, Richard Trethewey, around here someplace. He's the systems expert on This Old House. Hey, Richard.
Hey, Steve. All right.
Doesn't it feel weird to be back in school?
If you think it feels weird for you, you should think about me. I went here.
You're kidding. You graduated from Dedham High School?
Yeah. Well, it took me about 6 years.
2 to 5 times more polluted inside than outside, Richard. How can that possibly be?
Think about the issues. This is a sealed box. Concrete block construction, tight windows. They added all these kids come into the room every day, breathing, high moisture in their breath. How about at night? They want to clean the floors, there's solvents to deal with. Don't forget the wood shop, the auto shop. This is a home ec class. You've got cooking smells. All sorts of things inside the box. Also, we have
Chalk dust?
Right.
That's an allergen.
Absolutely.
Isn't it? Okay, so you've got all these conditions that produce pollution. How do you get rid of it?
Well, you got to bring in air from outside, and you have to get the stale air out of the building through an exhaust fan.
Simple enough. How do you do that?
Well, this building was built, I think this part of the building was 1957. And here is your basic 1957 heating and
ventilation system.
Heating came out of here, and if you need ventilation, you open the window.
And then how'd you vent the stale air?
There's an exhaust fan that pulls the air outside the building.
Well, this is about as crude as opening the flap on a tent.
Yeah. It's inefficient, and it's uncomfortable, really.
So there's got to be a better mousetrap.
Right. Well, in about 50% of the classrooms in America, this is the solution. This is a unit ventilator. And the way this works is air from the room gets drawn in through the bottom. It gets conditioned through a heating coil up here and blown out into the room already warmed.
All right, so it comes in here, it goes through this filter, and then you've got 1, 2, 3, 4 blowers, and you're saying there's some heating coils up here.
Right.
And then the air comes out here.
But the important difference is it has a connection to outside, so that outdoor air can come in through this damper. And before it gets into the room, it goes up and is conditioned. So it's much more efficient.
Now, the EPA has put together a voluntary checklist to help building managers and custodians make sure that these units are running efficiently. So what are some of the key points on that checklist?
Well, first is filtration. You want to start by changing the filters regularly, about once a season.
This one looks brand new, by the way.
Right, it is. You want them to be the correct size, obviously, and they should be installed correctly. There's an airflow arrow that says that this one's done the right way.
Okay.
You also want to be sure to have this be clean, so to vacuum down inside where any dust could accumulate.
Looks pretty clean.
Right. And then you want to be sure that the dampers to outside operate, but also that the controls that tell the dampers to open are operational.
Okay. Now, heating engineers recommend that a certain volume of outside air be brought into a classroom. They have a specific number for that. Even if this thing is working correctly, how do you know that that correct volume of air is being brought in?
There's only one test that you can do, and it has to be done outside.
Now we're outside that home economics classroom.
Right. This is the intake grill for the unit ventilator just inside. Now, in the old days, you could tell that you were getting some air into the building by, throwing a handkerchief up there and seeing if it stuck. And, well, we could tell that air's going in. But you could never really tell how much air was going in. Nowadays, if you wanted to know that, they have an invention called a flow hood.
A flow hood. This is bizarre looking. It's got sort of a hood on it that's made out of nylon.
Yeah.
And what's inside?
There's a sensing device here that can monitor how much air is going in or coming out, depending on how we program it. And it has a digital display right here that'll monitor in cubic feet per minute. So we put it right down over the intake.
Yeah. Center it there. And watch the numbers.
Okay.
293.
Yeah.
282. 382.
Okay. So we're in the high 300s. You know, what we're looking for, Steve, is about 15 cubic feet per minute per person. So, I mean, at almost 400, we got enough for 25 and more students.
Okay, so there's plenty of quantity of air.
Mm-hmm.
Now, on your checklist, is there anything we have to do to maintain this grill?
2 words to remember is quantity and quality. On the quantity side, we know right now we're getting enough air in there, but you got to watch out for obstruction. You don't want a chance of leaves or trash or something else blocking the intake. And you know, a snowbank or snowdrift could also get in the way.
Right.
So one is to protect that these are always clear, and the other is on the quality side. You know, they had a complaint in this building some time ago that, you know, they were getting fumes inside the building. Well, it turned out that cars used to park here, and they'd idle, in the winter, they might idle for 35 minutes before
warm
they...
them up.
That's right.
At the end of the day.
Well, the exhaust fumes are going inside the building. You'll notice now it's a no parking zone. And that's what you got to think about, keeping the cars away, the buses, the dumpster.
dumpsters?
Yeah, I mean, if you put one of them near the intake, that would be a problem as well.
So it's fairly common sense stuff.
Absolutely, yep.
And it is also covered in the checklist, right?
Right.
Now, is the whole building heated and ventilated this way, Richard?
No, in the new part of the building, there's another system. Let me show you. This library addition was built in the 70s. Up on the second floor is the library. Below it's a cafeteria. Now, there wasn't a lot of outside walls, so that unit ventilators really couldn't be considered. What they installed was a ducted system, which is a series of supply outlets along the outside wall.
Well, you can tell their supply because they've got the diffusers to spread the air.
That's right. Now, for as much air as allowed into the room, we have to be sure that we have the same amount going back to the unit to be reconditioned.
So how do you draw it out of the room?
Well, there's a return air register right here.
And where does it get reconditioned?
Right above us. Hey, Steve, up here we're on the roof of the old part of the building.
Now, Richard, did you ever used to sneak up here when you were a student at this school?
You know, if I had known that panel was there, I probably would have. All right, now this is one of the exhaust fans for the building, for this part of the building, and the checklist rule is if kids are in the building, these fans are on all the time.
How come?
Well, you know, it's quantity and quality. You're not going to get the right amount of air in through the unit ventilators downstairs unless these are pulling air out of the building.
So these really complete the circuit. Fresh air is drawn in through those unit ventilators that we saw.
That's right.
Stale air has to come out
That's
here.
correct.
And I see a bunch of them up
Yeah,
here,
they're
too.
all over this part of the building.
Okay, so I get that part of it. What about the library system?
Well, we're here. This is the roof of the library, and what you don't see below this roof is an elaborate series of ductwork that comes back up to these rooftop units.
And there's 1, 2, 3, 4, 5, about 6 of them up
Right,
here.
and they service different parts of this building addition. I want to take you down this end first to start and explain how they work.
All these units are the same?
Yeah, very similar, yep. First thing is, fresh air is allowed to come in through this grill. Behind it is a damper. Now the damper will open and close automatically, really with the changes of the season.
Okay.
Below here is the return air plenum. The air comes back from the building, it mixes with the fresh air.
Yeah.
It now comes in to here. This is a relief damper.
What does
What
that
happens
do?
is, you know, if all of a sudden all the windows in the building and doors are closed versus open, it allowed for a change in pressure inside the building.
So the unit would pressurize the building in that case. This would open up,
Yeah.
depressurize
Yeah.
the building.
Next
Got it.
is a filter module. Behind here is an elaborate series of filter racks, which will clean the air before it goes back to the building.
All right. What about this one?
Well, in the cooling mode, this is the module here for air conditioning.
I see some condensate down here, so
That's
it must
right.
have been running recently.
Right. Now we come to the heating module. This is really a gas furnace that will heat the air, and then the flue products will come out through this chimney.
All right.
And then finally the air is sent back to the building through another series of ductwork that goes back to the library area.
What about this one at the end, Richard?
Well, this is how the air conditioner works. This is the cooling condenser. The heat that you've taken out of the building is dumped to outside through this.
So this corresponds to the outside unit in a domestic system.
Yeah, right.
What are some of the considerations we face with these rooftop units?
We just got to protect what kind of air is allowed into that grill at the end. So first thing is right here. This is the exhaust pipe for the furnace. If the wind was blowing the wrong way, you might get a little smell of gas and fumes into the end.
Is there a remedy?
Well, if you need to, you could extend the pipe a little bit higher. It looks like they did it over at this unit right here to get it up and away.
Huh.
You also want to watch out for standing water. Now, here at the cooling module, you really don't want a lot of water because it's a perfect breeding ground for bacteria and mold.
And if you do get a lot of standing water, what's the remedy?
Well, you either have to make the roof be pitched so it all goes away, or this pipe has to run to a proper drain.
Anything else?
Well, I see over here there's one more item, and that's the pipe from the plumbing stack. Now, right below here is all the bathrooms in this area. And this is sewer gas, which is coming out all the time.
Now, it smells unpleasant, but I understand it's also noxious. It can cause headaches and other health problems as well.
Now, I think we're far enough away in this case. We're more than 8 feet. But if we were a little bit closer and it was a problem, what you would do is extend that pipe up higher to keep it away from the intake.
Now, there's a healthy checklist that covers maintenance on these rooftop units.
Yeah, and I think to illustrate the checklist items, we've asked somebody to pull apart the unit down the end. Let me show you that. Okay, now that's our filter rack right there, Steve.
Yes, but the first item on the list, Richard, is a safety check.
You should always make sure the electricity is off before you service any unit.
And we've done that.
Absolutely.
All right, inspect air filters on ventilation equipment.
Right. What you really want to have is clean filters. Now, these are replaceable style filters. These are brand new, and that's the way they should look.
How often should they be replaced?
At least once a season is a good rule of thumb. Now, you also want to be sure that there's a correct fit. You really don't want any gaps, because if there was a space between the filters, air would choose to not go through the filter and give you trouble downstream.
And I see an airflow indicator on here.
That's correct. There's a right and a wrong way to install it. You want to be sure the air goes this way through the unit, and so you follow the arrow.
Now, there's some old-style filters that some of these units have.
Right. Now, some schools will have a metal-style grill, and the maintenance issue for this is to be sure you wash it really well at least once a year.
At least once a year. Another item on the list, ensure that heating and cooling coils are clean.
Right. Well, if the filter didn't do its job or was poorly installed, the stuff would settle on the coil and would give you trouble. So you do a visual, and you'd find that this looks fine. Absolutely, there's nothing in there, and we don't have to do
this
anything.
one's clean, but what if it was dirty?
Well, you'd have to either vacuum it or wash it with a high-pressure wash, a coil wash.
Seems straightforward enough. Ensure that condensate drain pans are clean and drained properly. Where's the drain pan on this baby?
All right, well, that's right here, Steve. This is the cooling coil, and water will settle down off the coil and sit down here. Now, you're always going to have some water when the cooling is on, but you don't want to have standing water for the reasons we talked about before.
Because mold can grow there and contaminate the whole system.
That's right.
All right. And now we've got about 4 pages of checklist items on outdoor air controls and controls for air supply and so on. What's that all about?
Well, there's a lot of systems going on here. There's 2 sets of dampers here with motors and linkages. What happened during the fuel crunch in the 70s is many schools disabled those dampers because they didn't want the heat getting out of the building.
So therefore, they weren't getting fresh air through the system.
That's correct. So at least once a year, you should check that the controls are working and the dampers are working to be sure you're getting fresh air into your building.
Well, it seems kind of complicated to me, Richard. Can your average maintenance person take care of all this stuff?
Well, many schools will have people in-house that, in concert with that checklist, would feel comfortable to do this. But if not, what you do is you bring in a good local professional.
Okay, sounds good.
Great. Hey, before you go, once you give me in, you get that panel. We got to get this thing buttoned
You're
up.
going to put me to work, huh? Did you ever think you'd come back to your alma mater to talk about indoor air quality?
Steve, I didn't even think they'd let me in.
I can understand that. Now, using a checklist to evaluate a ventilation system makes a lot of sense, doesn't it?
Well, I mean, so much of it's just common sense, but the checklist helps you go step by step and not miss anything.
The EPA has developed the checklist, but they're packaging it with a whole bunch of other materials.
Right, there's a whole kit. It's called Tools for Schools, and it's really everything you need to know about indoor air quality for schools.
To order your Tools for Schools kit, call 202-512-1800 and ask for kit number 055-000-005036. Kits cost $22 each. Visa and MasterCard accepted.
Well, Richard, thanks for helping out today.
That was good fun.
Now, aren't you going to go say hi to your old librarian?
No, Steve. I think I still have 2 overdue library books.
Ooh, those fines are going to be big.